For decades, astronomers looked past the asteroid belt and assumed they were seeing a static, frozen graveyard. The giant planets were thought to be featureless spheres of gas, surrounded by dead rocks floating in the dark. This map shows the celestial mechanics that finally allowed us to reach those distant worlds. In the 1960s, scientists noticed an imminent, rare alignment of Jupiter, Saturn, Uranus, and Neptune, a configuration that naturally occurs only once every 176 years. This precise arrangement meant a spacecraft could harness the gravity of one planet to sling itself toward the next, requiring very little fuel. In 1977, we used this slingshot trajectory to launch the twin Voyager probes. These vehicles were equipped with technology that, by today's standards, is incredibly primitive. Their data recording systems relied on 8-track tape, and their television cameras were hurled blindly into an environment of extreme radiation and deep space cold. By sending physical hardware across millions of miles of space, we stopped peering at the solar system through distant lenses. We actively stepped into the cosmic dark to see what was actually out there. When the probes reached Jupiter, they found a volatile, hyperactive world. The planet is dominated by a tropical cyclone 3 times the size of Earth that has raged for at least 400 years, and it generates a magnetic field 20,000 times stronger than our own. This cross-section illustrates what the Juno spacecraft later discovered hiding beneath Jupiter's swirling clouds. As you move deeper toward the core, the immense pressure forces the hydrogen gas to compress into a liquid state that takes on bizarre metallic properties. Moving 1 billion kilometers further out to Saturn, the probes navigated the planet's iconic rings. They prove these structures aren't solid disks, but instead are made of countless chunks of rock and ice colliding at 80,000 kilometers per hour, effectively raining material down onto the planet's surface. But the most shocking discovery involved the moons orbiting these giant worlds. The massive gravitational pull from the host planet creates an intense tidal tug-of-war, causing the rocky interiors of these moons to physically bulge and flex, generating immense internal heat through friction. We see the violent results of this tidal heating across the outer solar system. Jupiter's moon Io is warped so intensely that it spews a ton of sulfur dioxide into space every second from hundreds of active volcanoes. Nearby, Europa's shifting ice shell conceals a subsurface liquid ocean containing more water than exists on Earth. At Saturn, the Cassini probe confirmed similar activity on the moon Enceladus. The spacecraft flew directly through thermal geysers spraying from surface cracks, tasting the salt water and detecting complex organic chemistry erupting right into space. The immense gravity of the gas giants acts as an engine, keeping the cores of their icy moons warm. These harsh gravitational forces created the exact conditions necessary for liquid water, making these frozen satellites our best candidates for finding extraterrestrial life. Past Saturn, the sunlight dims to a fraction of a percent, yet the ice giants remain incredibly chaotic. Uranus spins on its side with an extreme 98-degree axial tilt, while Neptune whips its thin, freezing atmosphere into storms with winds exceeding 2,000 kilometers per hour. Neptune's gravity also captured Miranda, a small moon that appears to have been smashed apart and reassembled. Its surface is a fractured mess of deep furrows and sheer cliff drops over 20 kilometers high. 4.5 billion kilometers from Earth, past the ice giants, lies the Kuiper Belt. When the New Horizons probe finally reached Pluto in 2015, the images sent back over a slow 1 kilobit per second connection completely defied our expectations of a dead rock. Instead, we found a geologically active world. Vast glaciers of nitrogen ice creep through valleys, carving their way beneath jagged 3-kilometer-high mountains made of solid water ice, all sitting beneath a blue, nitrogen-rich sky. A map of the Kuiper Belt reveals an anomaly. The orbits of distant rocky objects don't distribute randomly. Their paths clearly cluster in the same direction. Mathematical models of this alignment point to a massive, unseen super-Earth, dubbed Planet 9, orbiting tens of thousands of years away. Every time we expect the edge of our solar system to fade into quiet, empty space, the data proves otherwise. Pushing our physical reach outward continually uncovers active geology, extreme weather, and massive gravitational mysteries. The early assumption that the outer planets were simply cold, dead spheres has been entirely dismantled. Over the last 50 years, our robotic explorers have shown that the edges of our solar system are violent, dynamic, and complex. In 1990, Voyager 1 performed a final photographic maneuver. From a distance of 6 billion kilometers, it turned its cameras backward to capture a panorama of the inner solar system. Caught in a single, scattered beam of sunlight was Earth, taking up less than a single pixel. Seeing our entire history, everyone we know, and everything we have ever built reduced to a speck of light provided a sharp reminder of our actual scale in the universe. Both Voyager probes have now pushed past the heliosphere, the boundary where the sun's solar wind gives way to the interstellar medium. They are currently flying through the absolute void between the stars. Strapped to the side of each spacecraft is a golden record. These analog discs carry 115 images, 90 minutes of music, and spoken greetings in 55 languages, complete with etched instructions on how to play them. We launched fragile instruments out of our atmosphere to map a freezing frontier. By doing so, we gave our planet a voice, ensuring that a piece of humanity will continue drifting through the galaxy long after the probes finally go silent.